Alright boys, so the strategy is we're going to do all of bronze and then all of gold. Okay, fine. Maybe not all of gold because those videos take me a while to make, but we'll see what we could do. Also, what's wrong with my hair, dude? Literally, it's fine for school because I get to put on headphones and it kind of like, you know, squeezes this stuff together, but now I don't have headphones. And literally, these headphones that make it like look even worse, right? I don't know. You know, whatever. We might as well wear the gamer headphones. Why not? Why not? Okay, no, this sucks. God dang it. Hello everybody, I'm Kara, and today we're going to be going through the entire USACO 2019 December contest bronze. Okay, it's going to be epic. Cow Gymnastics, okay? In order to improve their physical fitness, the cows are taking gymnastics. Farmer John designates his favorite cow, Bessie, to coach the N other cows and assess, okay? In each of the K practice sections, she ranks them, alrighty. And then she is curious about the consistency, okay? So each one has a ranking, okay, and you basically want to see the number of consistent pairs. Alright, so what does it mean to be consistent? It basically means that one number is before the other every single one of the times. And N and K are tiny, right? Like literally you can just choose any pair, right? Like 20 choose 2 is still tiny, and it'll work, right? We could do that. Honestly, in bronze, don't overthink it. You literally just code that out. Let's see if there's a slightly smarter way to do it. Let's see. So if it's not consistent, it basically means that 2 are flipped in one of them. So essentially, let's just say that we like take the first one and rank it as 1, 2, 3, 4. So whatever the first ranking is 1, 2, 3, 4. Okay. So 4 is 1, 1 is 2, 3 is 3, 4 is 4. Okay. And then in here, the reason why this doesn't work is because now 3 used to be 4, but now it's before. Is there a smart way to do this? I'm pretty sure there's not a particularly smart way to do it. Why don't we just code it up? Okay. This is bronze. Okay. Don't need to overthink it. Alright, so we'll make a Python REPL. Let's see. We'll do, what is it called? Gymnastics. Okay, so we basically gotta do f is equal to open gymnastics.in, and basically we have n comma k is equal to imp0 dot split by spaces. Okay, and now we basically want to go through each pair and just make sure that it's always going to be the same. Okay, so we first need our initial ordering, right? Initial ordering is equal to that, and what we're going to do is we're going to do for I in range n, we're going to do first is equal to imp1, which is basically the first line, right? The 4, 1, 2, 3 dot split by spaces. Probably should do this right there. Alright. And then we should probably map int to this real quick so that there's int actually. Okay. And then we're going to go through each thing, and first we'll map split into this too. And we'll do initial ordering, first I, is equal to I. So that basically means that 4 is going to have initial rank of 0, 1 is going to have initial rank of 1, 2 is going to have initial rank of 2, and so on and so forth. Okay? And then we basically want to go through the rest of the things and just make sure that they're still in the same order. So I in range k, right? And then we want to go through each pair for every single, we want to find the current line, right? From 1 to k, imp I plus 1, and that's car. Okay. So now we have the current line as an array of integers, and we basically want to go through each pair in this array. So j in range n for k in range j comma n. Alright. And then we should probably keep a dictionary of which ones are valid, right? Or we could literally just have a two-dimensional array. So we could do our valid pairs is equal to array of size n for I in range n. Alright, so now we have an n by n matrix, and we basically want to store in like I comma j whether this pair is valid, right? Or wait, we only had to store how many. Oh, we only had to store how many there are. Oh, but still, yeah, we should probably just keep an array and then count it at the very end. So if car I is greater than car j, right? So basically what we know is that j is always going to be before k, right? So essentially we need that our initial ordering is also has the, like if we have 3 before 2, right? Like j is 2 and k is 3, then we need that in the previous initial ordering we have that 2 is after 3, right? So essentially we need the thing at j to be before the thing at k in the initial ordering. And then if in the initial ordering it's not, the thing at j is actually not before the thing at k, then we have a problem. In which case we have to say that it's no longer a valid pair, so we do valid pair j comma k is equal to false. So now at the very end, our valid pairs is going to basically have true for everything except the pairs that are not valid. So we'll just go through all the pairs for I in range n, for j in range I to n, and we need j to be strictly greater than I, so that should be I plus 1, should be j plus 1, okay? and we're going to do valid pairs ij. If it's true, then we are going to increment our count by 1. So we'll do count plus equals 1, and we will do count is equal to 0. And at the very end, all we got to do is print count. Okay, nice. So let us make our gymnastics button. Copy paste this boy in. Let's go. Okay, and we run it. String has no. Wait, what is it? What was it again? I forgot. Oh, strip. Yeah, that's what I did. Not trim. What am I doing? Okay, probably should list these boys. Oops, this should be -1. Okay. Oh, whoop, this is not working. Okay, let's see. Print, and... Oh, what? Well, why did they give them the other order? What the heck? Why the K, comma, N, dude? Bruh. Alright. So it prints out 3, which is not right. Okay, we just need to make sure that we are doing all the stuff. Oh, yeah, okay. Initial ordering, oh wait, let's just do, so initial ordering car J -1 and car K -1, that's what it is. And if that's the case, we do this right here, okay. And we'll also set the other side to false also, K and J. Okay, nice, so now that's working. Okay, let's just get the output working. Alright, nice, okay, so let us try submitting, and it should be fine. Bruh, dude, my Wi-Fi just stopped working on my computer, but now we are good, so let us continue where we left off, god dang it. Okay, so we were doing December 2019 contest results, okay, and now let us put in our answer. Hey, okay, seems legit. Now we move on to number 2, let's see what we got. Where am I? Farmer John has gone out for a walk down the road, and now thinks he may be lost. Wait, hold up, let's go back. Along the road, there are N farms, okay, 100, only 100 in a row. He unfortunately does not have house numbers, making it hard for Farmer John to figure out his location on the road. However, each farm does have a colorful mailbox along the side of the road, so Farmer John hopes that if he looks at the color of the mailboxes nearest to him, he can uniquely determine where he is, okay? Each mailbox color is specified by okay, so sequence of N, okay. And he wants to find the smallest value of K such that if he looks at any sequence of K consecutive mailboxes, he can uniquely determine where he is. Okay, alright. So we cannot set K equals 3 because there are multiple ABCs. Okay, so basically it's just asking what's the smallest K such that there's only one of each like set of K letters in a row, right? Like there's only, if we say K is equal to 4, there's only one ABCD. The reason we can't do 3 is because ABC appears twice, but there's only one ABCD, there's only one BCD8, there's only one CDAB, and so on and so forth. Okay, so how do we code this without... Okay, technically we can literally just do brute force, right? We can literally just do, go through all, like, K's, and then go through all N's and see which one works. But there should be a slightly smarter way to do it. So let's see. If we find... So we can find repeats, right? And then for repeats to stay repeats, they have to, when you add one more, that one more has to be exactly the same, alright? Okay, let's just do the brute force way. Basically, the idea is, all you gotta do is you just go through it, and you check each K and then see which is the first K that works. Now, theoretically, we could do binary search, but I don't think that is necessary. Is it necessary? I don't think it is. Let's see. I mean, if we wanted to do it fast, we could do binary search, but it is not necessary. Let's just do normal linear search. Okay. Alright, so what we're going to do is we're going to f is equal to open wheremy.in. And then our n is equal to int 0. Okay. And then our mailboxes is just equal to imp1. Okay. So basically, what's the best way to do this? What's the fastest way? Okay, so obviously we can just put a dictionary to keep track of which ones there are and make sure there's no overlaps, right? You don't access the same place in the dictionary multiple times, that works. Yeah, why don't we just go with that? So basically we're just gonna loop, so for I in range n, right, our K could go from 1 to n, or 0 to n, and all we're gonna do, or it should probably go from 1 to n, okay, n plus 1. And essentially what we're going to do is we're just going to have a dictionary, right? We're going to have dict is equal, or that's already taken, let's say, taken is equal to a dictionary. And then we're just going to go through each thing at this particular length, right? So we could do for J in range, you could start at the very beginning, and you could go all the way up till n minus the length, plus 1. Okay, sorry, minus 1 over here, okay. And basically we just got to add the substring from J to J plus I, to our dictionary, and if it's already taken, then we say that that's bad. So current is equal to imp, we go from j to j plus I, and we do if taken car not equal to 0, then we, what do we do? Then we continue. Otherwise, we just do taken car is equal to 1. And if we ever get past this for loop, that means that this works. So we're just going to, and if it ever leaves the for loop, then we just gotta print out our number and we're done. So we're gonna have final answer is like 0, let's say, and then we're just gonna say final is equal to I, and we are going to break. Okay. And then at the very end, we want to open our out file. Oh, our string not hashable. Hold up. wait, what? Not no. We need mailboxes. Okay. And if it doesn't exist, we want to default it to 0. So let's do taken.get and then car comma 0. Alright, so it's giving us 1. What is the problem here? So basically, it's going to do j to j plus 1. Alright. So check if it's not equal to 0. If it is not equal to 0, it would continue, but it doesn't. So it does taken is equal to 1, and then it should go through it. What? Hold up. Just print car and see what happens. Wait, so why doesn't it get taken? Wait, what? Okay, wait. Let's just print taken car, or get taken car. Wait, what? Then shouldn't this be satisfied? Oh, it continues. Okay, so yeah, so this should be, okay, it should not get to here. Okay, yeah, maybe we should do like a valid is equal to true, and then if this ever happens, we do valid is false, and only if it is valid, then we do this. Alright. Okay, nice, so that is working, and we could submit this. Alright. Okay, Python. Alright, Python, and we go here. Alright, we did another one. Let's go. Easy. Just kidding. Watch it be wrong. This is gonna be so sad. Hey, let's go. Okay, and the last one. Livestock Lineup. Alright. Every day, farmer John milks 8 dairy cows. Yes, okay, nice. Bro, why are they all B's, dude? You gotta go A, B, C, D, E, F, G. Bro, what a guy. The cows are rather picky, unfortunately, and require that Farmer John milks them in order. Okay. Alright. Why are there only 7 constraints? Alright, whatever. Okay, so you want to find an ordering of cows that satisfies all of them. Okay. If several ordering, and then you want to, okay, so you want the alphabetically first one, and it should have the lowest, yeah, okay. No, what? Bruh, what? Okay. Well, why do we have to, this one's bad, why do we have to do this? Okay, fine. Alright, so basically the idea is we want to keep track of who has to be beside who, and then we know that they have to be next to each other, so what's the fastest way to do it? Is this in alphabetical order? Hopefully it is. No, it's not. Come on, why didn't you give it to me in alphabetical order? Bruh. Well, basically, if we know that somebody is between or beside 2 different cows, we know it has to be in between those 2, right? So, essentially, okay, so the first and last people have to be beside only maximum of 1 person. I mean, couldn't we just we literally just go through every single possibility and check if it satisfies the constraints that works, but that is kind of nasty. Huh, maybe in this case it might be good to draw a diagram, let's see. Okay, so basically you have we'll just pretend they're A, B, C, D, and E because that's easier. I don't know why they didn't give us A, B, C, D, and E. That would be so nice of them. Okay. And essentially we were given that some people are connected to others. So essentially these guys gotta be next to each other. It doesn't matter what order. And if there's ever a cycle, we know that there can't be a cycle because that wouldn't make sense. Because then, there's no way to put these guys in a line such that, all 3 of them are next to each other. So there's no cycle. That is a good thing. So they're just going to be, lines. And if we did, for each line, we could either put it one way or we could put it the other way, right? We could go C, D, E, A, B, or we could do B, E, A, D. So if we find the number of lines. Okay, so, okay. So basically we need each line to be, have the, we want to put it in alphabetical order, right? So if we have these 2 lines, separate lines, we want to put BEA somewhere and we want to put CD somewhere. And then we look at the first guys in each line and we say, okay, B is before C, so we do BEA CD. Okay, that's the strategy. Let's try to implement it. That's going to be epic. Alright, so we just do lineup, okay, and we'll do our normal read-in stuff. Okay, so now we just need to find the relationship between the different guys, right? We want to find the lines, right? And we could basically do that using an adjacency list. So we know that the heads of the lines, right? The guys at the either end are only adjacent to 1 guy, and we know that everybody in between are adjacent to 2 guys. So the idea is, yeah, okay, so we could have what's a good way to do this? I mean, technically union find is the best way to do this, but like we might as well just do. Wait, yeah, union find would be epic. I mean, not that it matters. Okay, yeah, literally just 7 cows. So basically, we're just gonna keep track of which group each one is in, and we're gonna keep track of how many neighbors it has. So neighbors is gonna be equal to how many guys are there? 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we'll have the we'll have group. Yeah, group is equal to I for I in range 8. Okay, so the 0th cow is in group 0, the first cow is in group 1, so on and so forth. And let us arrange these guys in alphabetical order. So cow equal to Bessie. Bro, they're so troll, what the heck? Okay, first off, they don't choose good names, okay, that's one thing. And then second off, they don't give it in alphabetical order, god dang it. I suppose that is the point of coding, but we don't talk about that. Bro, this is such a cancer problem. Why do they have to put like string bashing? Illegal. Oh well, groups won't work. We'll have to figure out a better way to do that. Well, we just need a list of their neighbors, so we'll do like this for I in range 8. Okay. Okay, so now we gotta do our string bashing, so we're gonna do I in range n, and we're going to take, we should probably just do imp.pop to save us some trouble. And now we gotta take the last guy and the first guy. So how many? So 0, 1, 2, 3, 4, 5. Okay. So basically, the 5th guy is gonna be our second name, and the 0th guy is gonna be our first name. So we'll take car is equal to imp I dot split by space, and we'll take first is equal to car 0, and second is equal to car what? 5. Okay. And what, we gotta go from name to number now though. Hold up, now that is annoying. Okay, so first off, we gotta sort this guy. So we do sort cows, alright. Or we do cows is equal to cows dot sorted, okay. And then we want to make a map, basically. So we want a map of numbers to, we want like this. Okay, so now, let's just test it. So let's print, or num to cow. Num to cow 0. That should give us Beatrice. Okay. Whoop. Lineup dot in. Okay. Oh, oops. Oh, oops. You do this. Alright. Now that should work, I think. Okay, so Beatrice is first. That is good. Our num to cow is working. And basically, we're just gonna add the 2 cows add each other's neighbors, right? We're gonna do neighbors, num to cow. We're not gonna set the numbers, so we'll do for num to cow here. And now we just add each other as neighbors. So neighbors first dot append second, okay, and then same thing for the other way around. And then at the very end, we should be left with neighbors. And we want to take the, we basically want to take the, what is it called? We want to take the heads, right? We want to take the guys with 1, and we want to sort it. Okay, so we'll take heads is equal to that. And we'll do for I in range, not n, or is it n? Yeah, n. So here it's 8. If len neighbors I is equal to 1, then we want to do head dot append I. Okay. Or, well, we want to append, what do we want to append? Oh, well, yeah, that's how we want to do it. And essentially, yeah, so now basically what we're going to do is we're going to start with a head, right? We're going to go through, right? Or basically, or it's 0. If it's a 0, then it's also a head, right? It's a head of its own line. It's just by itself. So or actually, let's say less than 2. So now we just have our final is equal to that. And basically, what we're gonna do is we're going to go through all of its neighbors, right? We're gonna put the head down, then we're gonna go through all its neighbors until we reach the end, and then we're gonna put down another head and go through all its neighbors until we reach another head, and so on and so forth. So car is equal to neighbors I, right? And then we're going to do, so if it's 1 okay, so it's obviously 1, so we're just going to, it's 1 or 0, so we're going to place a head, final dot append I, and then we're going to check if it has a neighbor. So if len car is greater than 0, we are going to go through and append all of its neighbors. Okay, and we should keep track of who we placed, so let's do place equals that. Bro, this is such an annoying implementation problem, god dang it. So then we're just going to go through it while the len of car, Yeah, I think we could just do while len of car is equal to 0. Okay. So while len of car is equal greater than 0, what we're gonna do is we're going to set our car is equal to what? Well, it should be 1. We're gonna keep our car as always 1, so we'll do equal to neighbors car 0. Okay. Oh, but we also have to keep track of our prev. Okay, so we'll have a prev is equal to I. And basically this moves on to our next thing, right? Okay, we should say car neighbors here. And then this should be car. So basically we set prev is equal to car, and then we say car to the next thing, so that's car 0, and then we set neighbors to car neighbors is equal to neighbors car. Wait, we don't even need to do that, that seems like a waste of time. Alright, so we basically do neighbors car, and we don't want to go backwards, right? We want to just go forward, so we delete the previous guy, so dot remove prev, and then we add the current thing. So we do final dot append car placed, or we should check if this has been placed yet. Well, they can't be in multiple chains, so as long as, okay, we should just do if placed I break, or continue, okay. Placed car is equal to true, and that should be fine, okay. And then we just print final, let's see if that works. Oh, oops, dude, this is the nums to cow, right? And the dictionary should be cow to num. Okay, that makes more sense. Num to cow, and then cow to num. And it should go the other way around, so that would make sense. Oh, whoops, this should be just a array of like a bunch of falses, and it should be times 8. Okay, that makes sense. Int is not subscriptable car. What's car supposed to be? Oh, is equal to, it should be neighbor's car 0. So 0, 7, okay, so far so good. 1, okay, I think this is right. Okay, wait, let's see. Okay, so essentially what we want to do is we want to go through, for I in final, we want to print out num to cow, I. Alright, moment of truth, let's see it, let's go. And it looks correct, nice. Alright, so essentially we want to do right instead, so we'll just do f is equal to open the lineup. Oops, gotta have the enter, and we should be good. Hey, let's go. Okay, turn this boy in. Let's go. Bro, this took me so long because I really had to keep fixing the Wi-Fi for some reason. I don't know, this computer sucks. Hopefully this is right, it would be sad if it wasn't. I tried so hard. Hey, okay, there we go. Very nice. Alright, we are finally done. Thank you guys so much for watching. That took a lot longer because the Wi-Fi kept cutting out, but thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know what else you guys want to see. But other than that, thank you guys for watching again, and see you guys next time.